All right, welcome class. This is notes for section 1-6, scientific notation. The learning intentions today will be being able to compare numbers in scientific notation and standard form. And you're going to know you have this when you can go from standard form to scientific form and scientific notation to standard form. And then you can also list those numbers in scientific form in order from least to greatest or greatest to least. All right, let's take a look at what these notes have in store for us. All right, so this is why we use scientific notation, all right? Because sometimes we're going to have really, really big numbers, like the approximate distance from Earth to the Sun, 150 million kilometers. Or sometimes we'll have really, really small numbers, like the approximate mass of hydrogen atom. Not reading that, too many zeros. We can write these in an easier to use method. That is called scientific notation. Let's see how we can use this and what it looks like. All right, so like I said, scientific notation is just a really quick way, easy way of writing really big numbers or really small numbers. And we're going to do it in the form of a times 10 to the b power, where a is going to be an integer between 1 and 10, and b is just an integer, meaning it's a number on the number line. So for example, we have 2.3 times 10 to the sixth. That is scientific notation. So sticking with this example, we're going to talk about the different parts because you have to understand what I'm talking about when I use our math terms. So the coefficient is the number being multiplied by the 10 in the exponent. So in this case, 2.3. The base is going to be 10. In scientific notation, the base is always 10. And your exponent will be the number of times you are multiplying 10 by itself, right? Positive 6 exponent means it's 10 times 10 times 10 times 10 times 10 times 10. And that's a really big number, which is why we use scientific notation. Now we have different types of scientific notation, right? We have it with a positive exponent, and we have it with a negative exponent. We've already seen both examples of these in our Bell work last week or this week. When your exponent is positive, you are repeatedly multiplying your coefficient by 10. You are multiplying 2.3 by 10 6 times, and you will end up with the number 2,300,000. If it is a negative exponent, if you remember from section 1-1, negative exponents are repeated division. So instead of multiplying 2.3 by 10 6 times, you are dividing 2.3 by 10 6 times. So 2.3 divided by 10, divided by 10, so on until you get 6 times. And that will give you the number 0.00000023. So positive exponents are used for really big numbers. Negative exponents are used for really small numbers. Now here comes an important part. This is going to show us how we go from standard form to scientific and from scientific notation to standard form. So from these two examples, we're going from scientific notation to standard form. You have 2.3 times 10 to the 6th power. All you have to do is take 2.3 and move the decimal 1, 2, 3, 4, 5, 6 times. And then you would fill in all of those spaces with zeros, and they did that over here. So let's see, 1, 2, 3, 4, 5, 6, and your decimal is now at the end. And that is where they get 2,300,000 from. You just simply have moved your decimal 6 spaces to the right. Now when it's negative, you just do the opposite of that. Instead of moving the decimal to the right, you move it to the left. So it's still negative 6, so 1, 2, 3, 4, 5, 6. And you would fill in these blanks with zeros. 1, 3, 4, 5. And you can go over here more neatly than what I did. And you can see 1, 2, 3, 4, 5, 6. They have moved the decimal 6 spots to the left. So once again, positive exponents to the right, negative exponents to the left. Sorry, those are some terrible arrows. All right, here you can see we have 4 real life situations with some real life data and numbers. I am asking you to take these numbers that are written in scientific notation and rewrite them using standard form. All right, so pause the video at this point, take a couple of seconds and try to rewrite these numbers in standard form. All right, and here is your answer key to your little check problem. Take a look at your answers. Please note, if any one of these is very confusing to you, bring it into class and ask me or Ms. Franklin to clarify, all right? Come in with questions. We love answering questions. All right, so we talked about going from scientific notation to standard form. So I want to talk about the converse, right? Going from standard form to scientific notation. I'm actually going to use the exact same examples. We're just going to go the other way. So if you were to start with 2,300,000, and I asked you to convert that to scientific notation, you would start where the decimal is, and then you would move the decimal to a position where the number that is left is somewhere between 1 and 10. So for this example, it would be 6 times. 1, 2, 3, 4, 5, and 6. So it will be between the 2 and the 3. So your number will become 2.3 times 10, and the spaces you move, your decimal, becomes your exponent. So we moved it 6 spaces. The exponent is now 6. And I want to talk about why we moved it to 6 spaces. If you move it 5 spaces, your coefficient is no longer between 1 and 10, right? The number 23 is greater than 10, so that is not acceptable. If you move it 8 spaces, you are 0.23. That is less than 1, not between 1 and 10, unacceptable. So you have to remember your coefficient needs to be between 1 and 10. Now, on the same boat, if I gave you 0.000023 and I told you to make this very small number into scientific notation, you are going to do the same thing. You are going to move your decimal to a position where your number, your coefficient, will be between 1 and 10. So again, that'll be between the 2 and the 3, and you'll be with 2.3 as a coefficient. But this time, your exponent is negative because you moved it to the right instead of to the left. But I don't want you guys to get confused with right and left when you're going from standard form to scientific notation. So the real easy way to remember, do you make your exponent positive or negative, is look at your starting number. If your starting number is less than 1, your exponent is negative. If your starting number in standard form is greater than 1, it's going to be a positive exponent. So the key here, in summary, to go from standard form to scientific notation, make your coefficient between 1 and 10, and then count your spaces. The spaces you move will be your exponent, and the sign on your exponent will depend on your starting number. If bigger than 1, it's a positive exponent. If less than 1, it's a negative exponent. The last thing to talk about today is ordering numbers in scientific notation. So we have 2 times 10 to the 4th, 3.2 times 10 to the 4th, and 4.1 times 10 to the 2nd. So based on the exponents, you should know that 4.1 times 10 to the 2 is the smallest value because 10 times 10 is 100. 10 times 10 times 10 times 10 is 10,000. So these two numbers up top are in the 10,000s. This number is only in the hundreds. Therefore, it is the smaller of the number. So long story short, when ordering numbers in scientific notation, the first step is to look at their exponents, right? The smallest exponent is the smallest number. All right, and that's all you got to do. We'll talk about when they have the same exponents on the next slide. So we were comparing numbers in scientific notation, and we had already talked about if their exponents are different, the difference, or the number with the smaller exponent is the smaller number. But if the exponents are the same, like we have 2 times 10 to the fourth and 3.2 times 10 to the fourth, both have 4 as their exponent, then you compare the coefficients. Well, which coefficient is bigger? 2 is less than 3.2, so 3.2 times 10 to the fourth is bigger. It's that simple. So your final correct order would be 4.1 times 10 to the second because it's to the second power, so you know that's only in the hundreds. Followed by 2 times 10 to the fourth because that is 20,000. And 3.2 times 10 to the fourth is the biggest number because this is 32,000. All right? So that is how we order numbers in scientific notation. Putting it all together here, this is your only check problem for the notes, right? The distance across the universe, Proxima Centauri, the closest star to our own, the sun, is just, I don't know, very, very far away. This is a very large number in kilometers. What I want you to do is convert this number into scientific notation. And then you need to consider that a light year corresponds to a distance of 9 times 10 to the 12 kilometers. I want you to tell me which number is bigger, the distance in a light year or the distance to the closest star. So convert to scientific notation or convert to standard notation and compare. Tell me which one is larger. So we will go over that problem in class. That is something I want to talk about in class. So this is just going to be a summary, all right? Scientific notation. It's a shorter way of writing really large or really small numbers. Your coefficient needs to be between 1 and 10. Your exponent needs to be an integer and anything on the number line. Your base will always be 10. All right? Make sure you come in with these notes by next Monday, as that's when we are going to practice this standard. Have a good day.